So if you take a look at the graph here, these are the three graphs that we just drew, and you can see that the vertices here, here, and here are all in different places. They all have the same y-intercept, and the shape of these graphs are exactly the same. They will just lie right on top of each other. So what I've done here is I'm going to put a graph here, and okay, I'm going to add a slider for B. And notice that as I slide it, I can, if I let B equal -2 or +2, there it is. If B equals -1, it fits that one. And if B equals -5, it fits that one there. Okay. Now just kind of watch the vertex and tell me if you can see what's happening with the vertex. So kind of focus your eyes on the vertex, and as you change that B value, you should see it trace out a parabola. So I'm just going to turn these off and just make so that we can see just that one parabola. So as you slide that, change the B value, the y-intercept stays the same, the shape of the graph and the orientation stays the same, but the vertex now traces out a path of a parabola. Okay, so that's what's happening. It does, the B value, and we're not going to get too much into it, but the B value does affect somehow, not in a concise way, it does affect the vertex, but how it affects the vertex is it is actually affecting it in a parabolic way, the location of that vertex. So that's just a curious looking thing. And we can connect some math to it maybe a little bit later on, but right now we don't really have enough math to be able to connect it to why that B value, as it changes, traces out a parabolic curve.